In this video, we're going to talk about evaluating arc-trig inside of trig and how to rewrite this with no trig at all by the final answer. So as a quick reminder, when we see, for example, sine to the -1 of x, that doesn't really mean -1. That means inverse sine, which can also be thought of as arc sine. Those things are equal. So we have that. Now the next thing I would like to remind us, is that our regular trig, for example, sine, has an input and an output. The input is usually an angle, whoops, not an angel, an angle measured in radians in calculus. In calculus, we always do everything in radians. The output is a side ratio. Now, remember, with inverses, the input becomes the output becomes the input. So for example, if I had inverse sine, well, now the y would be coming in and the x would be going out. Well, meaning now we have going in would be a side ratio, and the output would be an angle, and again in calculus measured in radians. So working from that, we're going to look at this and say, what do we have here? Well, we see arc-trig, which means what we're really looking at is a side ratio. We have a something divided by something. So the output of this would be an angle. So let's start building this. Let's figure out what we're actually looking at. So the first thing we're going to talk about is what is the side ratios for secant? Well, if we remember, we have a funny little acronym to help us remember our side ratios, which was SOHCAHTOA. And the remembering that these are just representing sides of the triangle. So sine's ratio is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so notice secant's not one of those. Well, now we need to remember what is secant. Secant x is the same thing as 1 over cosine x. It's the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then what secant is the reciprocal. So it would be the hypotenuse over the adjacent. So what we're really looking at here, is kind of cool. This is the hypotenuse of our triangle, and this is the adjacent in our triangle. Now, what do we mean by hypotenuse and adjacent? Okay, so let's draw a triangle, and let's pick any angle other than the right angle to call theta. Now, it doesn't matter. You could have picked the other one to be theta. That would have been fine. You get the same thing. But what we're going to do here is we're going to say, okay, I am going to build, based off of this triangle, I'm going to fill in these side ratios. So I know the hypotenuse is opposite the right angle, so that's x plus 2. And the adjacent side is 4. Great. Now, if I wanted to, could I figure out this other side that I just called b? Well, sure, because b squared plus 4 squared equals x plus 2 squared, or aka a squared plus b squared equals c squared, Pythagorean theorem. So now we can solve for b squared. All right, so b squared equals x plus 2 squared minus 4 squared is 16, so minus 16. So b equals plus or minus the square root of x plus 2 quantity squared minus 16. And you could leave it just like that. You may want to in some situations, or you may want to distribute through and distribute through the x plus 2 quantity squared. So that give you x squared plus 4x plus 4 minus 16, which would simplify to be x squared plus 4x minus 12. Okay, so we're going to go ahead and fill in here. I'm going to go ahead and fill in here that this is the square root of x squared plus 4x minus 12. And the plus or minus is really going to come into play when we start talking about which quadrant are we in. It's to remember that this is representing a y value. So it could be up, it could be in the positives, or it could be down, it could be in the negatives. So we could either have like a distance of 4 where we're up, or 4 where our triangle is down, right, and putting us in quadrant 1 or 4. So the plus or minus can be evaluated at the end when we figure out what quadrant we're in. So let's move this out of the way so we have a little bit of space. Fantastic. Now, moving right along, If you heard that, that was me throwing my pen. Okay, so moving right along. Now we're kind of done evaluating the secant. We're really at the point where we're just saying, really, this problem's asking me what is cosine of theta. And since I have my right triangle, I can just look at my side ratios again. Remember, cosine was adjacent over hypotenuse. So therefore, I can evaluate this by saying, what is my adjacent? 4. What is my hypotenuse? X plus 2. And this is kind of the neat thing. I didn't even have to do the Pythagorean to do this problem because cosine and secant are the same side, using the same sides. It just they're the inverses of each other. So we are done. The answer to this problem, the answer to simplifying this would just be 4 over x plus 2. Okay, so now let's do a slight little extension. Let's make it so it's not the same side ratio. Let's pretend that our problem wasn't cosine. Let's pretend our problem was tangent of secant, arcsecant, not -4. There we go. Arcsecant of x plus 2 over 4. I wanted to leave the secant the same as the original problem because I want to make the point that our triangle would be the same, right? The outer function, whether it's cosine or tangent, doesn't matter. The inner triangle was built, the triangle was built off of the arc-trig. The arc-trig was the same, the side ratios are the same, therefore the triangle is the same. So now we are just, again, evaluating tangent of theta. So you go to your triangle and you say, okay, tangent is TOA, opposite over the adjacent. So therefore, tangent would be the opposite, which would be square root of x squared plus 4x minus 12 over the adjacent, which was 4. So hopefully this makes sense. Hopefully you can understand why when you see something that is so triggy, when you have trig inside of trig, specifically trig with arc-trig inside of it, when you're done simplifying, there is no trig left because it's always going to go to the triangle. We're always going to use our side ratios to find to be able to build our triangle, use Pythagorean to get the missing side, and then finally evaluate for theta. Now, I want to give one more example that tends to come up. What if we had something like this? Let's not do secant again. What if we had tangent of arc cosine of x? Okay. Well, we still have to think of this as the input is a side ratio, right? Because it is arc-trig, but it's not a fraction. Well, aren't all numbers actually fractions? We just have to remember that it's over 1. And now when we go to build our triangle, say, okay, there's my right angle. I can pick either angle to be theta, and I'm going to say, okay, so cosine is adjacent over hypotenuse. So therefore, my adjacent to my theta would be the base here, and then the hypotenuse would be a side length of 1. And now we could go through this problem again, using Pythagorean to find the missing side, and so on and so forth. So let's try that. Let's finish up this problem. All right, so to get our missing side, it's going to be, I'll call it b again, a squared plus b squared equals c squared. So therefore, we have x squared plus b squared equals 1. So b squared equals 1 minus x squared. So therefore, b equals plus or minus the square root of 1 minus x squared. So therefore, this is square root of 1 minus x squared. Okay, fantastic. Now we have essentially built our triangle. So we're really now just evaluating what is tangent of theta. And that would result in tangent is opposite over adjacent. So therefore, once again, this is going to be the opposite, which is 1 minus x squared over the adjacent, which is x. All right, and that is our simplified trig. Hope this helps.